yesterday. So why RIPE NCC and routing security? Because as you know, we mostly do the registration of IP addresses and AS numbers, but we also provide or ensure their unique allocation. We document them in RIPE database, and we enable you to put your information there as well. We've been involved in routing security for quite some time already. Back in 1994, the RIPE 181 document published or described the common language to describe routing policies. We were involved in developing RIR, and our database is one of the IRRs in the world. We've been active in developing RPK standards in IETF. Our validator was one of these reference implementations of several protocols. We've been there for a long time, and let's see some common concepts about how routing is working in current world. So BGP standard is quite old, and as any standard from that time, internet standard, it basically was built on the idea that everybody should trust everybody in the internet, because nobody is going to do something malicious or something bad, because it's a, I don't know, fantastic idea that we now could communicate, so why are we going to do something bad with that fantastic possibility? So basically, when two routers on internet speak to each other, the idea was that they should trust whatever they receive from the other side. And of course, this was not correct for a long time, because the first problem that occurred is that more and more routers connected to the global internet, the more and more mistakes became apparent. And the not so recent 2017 report on routing security by Internet Society showed that there were about 14,000 incidents in routing during the year, with 10% of all autonomous systems involved somehow or affected somehow, with 3,000 ASs being victim of at least one incident, and 1,500 autonomous systems caused at least one incident. But this was not the worst year for the internet, because later in 2018, things started to become more scary. So there are links to two reports or to investigations on what happened during that year. One was the BGP and DNS attack on Amazon, which targeted myetherwallet.com website, and some cryptocurrency was stolen, really stolen from real people. Second attack used the same techniques, but against different payment systems in US. So basically these things that happened, like with Simple Mail, transfer protocol SMTP, which also had no security planted into it, and then after many, many years, everybody knows what happened with spam and everything. The same started with BGP. And this probably is going to be more and more serious. It's been known for quite a long time that this is a problem, and it's not that nothing has been done to remedy this. So the first solution to remedy these mistakes basically was internet routing registries. This is basically a public database where operators could put information which network should be announced by which router. And then both parties, when they communicate with each other, could basically verify what they receive on the wire on BGP, verify this information with routing database, and then make a decision whether they want to allow these announcements or not. The routing registries by now, there is a huge list of them. There's more than one, there's more than 5, there are more than 15 of them, at least the big ones. This is both good and bad, because when you have more than 15 registries, the problem is that they are not synchronized with each other. In fact, every routing registry has its own policy of what is accepted, what is not accepted, how you could put data in there, how you could remove data from there, how you could protect that your data is not put in some other database or other way around. This leads to accuracy problems in RRRs. So here you could see that the data taken from our routing registry is more or less okay, but if you look at the global picture, it becomes not that good. And the local accuracy usually is below 50% or even lower in many cases. So to remedy this situation, we've got a new solution which is known as RPKI, Resource Public Key Infrastructure. And the idea is that when you put information in simple public database like normal IRR, there is basically no control who puts information there and whether it's correct. And the idea with RPKI was that because we have basically mathematical solutions to this problem, we could sign data cryptographically and everybody is able to verify this information. We put this theory in practice and we took ideas from the normal public key infrastructure and extended it to resources. So the idea was that we take whoever provides the resources could also give digital certificates for these resources that could be signed and could be verified later. And based on these certificates for resources, we could create more information. For example, create record which AS number is allowed to announce which IP prefix. This system was implemented since 2018 by all 5 RIRs. Because RIRs are basically entities who have authority on who has which IP resource. There is a big number of IETF standards that describe all of this, and essentially this system is already productional, and I invite all you to take part in it. So basically RPKI needs 2 big actions from you. First, you have to create these authorization records or routing authorization record ROA. And second, you have to validate this route on the receiving side. RPKI repository is basically a public database. It's not the same as WHOIS database or any other IRR database. But idea is the same. All objects are public there, and you just need special software to fetch it and validate. Yeah, so basically this is how it works. Why it's actually PKI, so why it's hierarchical. This is because, again, the idea of creating this system was following the model of how we distribute resources. So we have regional internet registries. They distribute resources to the local internet registries, who are typically just internet operators who distribute it further to their end users. And when the system was basically envisioned, the idea was that on each of these levels, you're going to have a so-called certificate authority. So the authority that will create digital certificates for one level below, which will sign them, and then everybody will be able to verify them. But essentially, in practice, not every operator would be willing to operate their own certificate authority, manage their keys, and do all these cryptographical things. So what happened in practice is that The model as it was designed initially, that you have a certificate authority on every level of this hierarchy, was simplified a little bit. So firstly, every operator who manages their end users could also manage their certificates without delegating them these possibilities, because the further down you go in this chain, basically the more you struggle with the wishes of people to maintain this additional technical complexity of having certificates, signatures, keeping everything secure, and so on. And secondly, all RIRs basically implemented by now a model when they also maintain all these keys and all this technical burden of signing everything for their members as well. So here in the middle you see RIPE NCC hosted system. This is what we built for you, that you could basically just go to our web interface and create all the objects there. The downside of this is, of course, that we are keeping all the cryptographic keys for you as well on our hardware and our platform, so you have to trust us with your keys. And if you do not, then you could also do any other so left or right solution for you. You could create CA for yourself and your end users, or you could create your CA just for you and ask all your end users to do the same on their level. So let's see how difficult it is, and let's see what you have to do if you decided I want to run everything on my own. What do I need to do? So there is RPK CA software, as it's called. At the moment, it is basically the old RPK toolkit, which was developed as RPK.NET initiative by Dragon Research Labs. It's now not being actively developed, but yeah, there is an open GitHub page, and these are the links to it. Recently, NLNet Labs also created their new solution for it called Krill. I know they talked to various operators to make them use it, so well, it's all up to you. You choose which one you want. So you download this software, you set it up, you install it, then, well, you are our member, so you have to go to our web portal and enable non-hosted CA, certificate authority, for you. And then you set up connection with our system, and then it basically just works. So how to do that? This is basically our web interface. The first page, if you go to my.ripe.net/rpki and you've never been there before, you will have to answer a simple question: which system you want? You want a hosted system that we manage, or non-hosted, which will be you. So in this case, if you decided I'm not going to put everything on RIPE NCC, I'm going to do everything by myself, you choose non-hosted model. After that, the RPK.NET solution basically provides you interface where to bootstrap the system, you download a file, which is normally called identity XML. It has some initial bootstrap information. You will have to upload it through this web interface. This will make proper records on our side, remember everything, and after that you will download our site file back, you put it back in your software, and everything magically starts working. That was the easy part, so we only covered first 3 steps of the whole thing. Well, after that there will be like automatic certificate signing request and response from your side to our side. This is also an easy step. After that, you will have to manage your repository. So this is the place where you will put your certificate, where you will put certificates of your clients, and where all the routing authorization objects will go. So the problem there that you have to keep it public, and you have to keep it updated. And by default, some RPK recommendation says you have to keep updating it every day. So the typical expiration on manifest objects and CRL object is 24 hours. Believe me, this is a tough problem to solve in the long term. It's doable, but yeah, then it will be up to you how you manage to do this. And also make sure that if you do it on your own equipment in your own network, and you manage to screw up your routing authorizations, nobody will be able to connect to you anymore. So even if you fix it and put correct version in your repository, until your old object expires, nobody will be able to download it from you. So yeah, think about it. It's not as simple as it could be. Let's see what you could do if you choose for the hosted model. So in this first page, when you go to our website, you could also choose hosted model, and after selecting this option, you basically appear in this interface, which allows you, so after that, all the certificates for your space that was allocated to you and your clients, the certificate is created automatically by our system and maintained and being kept up to date by our system. And this is the interface where you could create rows for your space, and it also it's combined with BGP announcements that we see on the internet. And basically the goal of this interface, that all the announcements for your address space that we see should become valid from the RPK point of view. So basically they should be covered by valid rows, which is very easy in our case, because basically for all these announcements you could simply click the button there saying I want to create row for this exact announcement, and the matching row will be created automatically. You could also do this all manually if you want to do some specific things. But basically to set up the whole system, if you don't have, I don't know, hundreds of prefixes, you probably need to spend about 45 seconds to set it up. And as we saw yesterday, it really took around that time for the only row that we created here yesterday at the above. So yeah, basically the result is that you're gonna have valid rows for all your address space, and yeah, these are the steps that need to be taken care of in this case, and it's all done by our system. The question we receive is how do we do this for our PI end users? Because the certificates that you're going to see there are basically for your space. What do you do with PI space and PI end users? This is also taken care by us. So basically what you have to do as a sponsoring LAR is you have to create a inetnum and org objects for your PI end users in RIPE database. You have to assign them a maintainer they have access to. And after that, your end users could go to this interface. They have to link their RIPE access account to the RIPE database maintainer in the database using this interface. So you will have to authorize both as RIPE access user and the maintainer in the database. After these two accounts will be linked, and you will be able to maintain resources that are associated with the maintainer through this RPK interface, exactly the same way as your LAR will be able to do it for their PA resources. And of course, sponsoring LAR by default has access to all the PI resources of their sponsored end users. So sponsoring LAR could also do this for their end users on their behalf. So these basically covered the first thing that you have to do is create authoritative records. What to do next? You have to run routing validation, which should be done close to your border routers. And then you have to inform your routers about these RPK objects that have been found in public repositories. So this is where these RPK validators come from, or come to. This is the software that basically fetches this information from public repositories, does all these mathematics to validate everything, and then gives to your router already like the validated information. So this is what we call VRPs, so that your router could then make a decision whether it wants to filter something out or not. This is the list of RPK validators. We have one of them, well, basically even two of them, version 2 and version 3. Version 2 has been written some time ago, and it is by now more stable but has less features. Version 3 is still a bit fresh, so I would say use it, try it, but don't expect much from it as of right now. We are still making it more stable. And LNet Labs also has Routinator, Cloudflare has Octo RPKI, and there is still this Dragon Research RPKI.net validator from old times. So validating route announcements. Basically, what you have is on the one side to your router you have BGP announcements from your neighbors. On the other side you have RTR protocol from the validator, which gives you these are valid ROAs that are found in all these repositories. And the outcome of matching these two things is basically valid, invalid, or unknown. And valid is if you have at least one ROA that covers the announcement. So basically the prefix and the origin in the announcements match what you have in the ROA, then the result is valid. If there is ROA for the prefix with different origin than the one which we see in BGP announcements, then this results in invalid announcement. And in all other cases, it's basically invalid. And it is your policy what you want to do with them and how strict you want to be. For a long time, it was basically the idea was that of course, if it's valid, we just accept it. If it's unknown, then we use default other methods of selecting which path we want to prefer. And if it's invalid, then we probably just will set preference for this route a bit lower than all the other things. And I would say for many years that was default practice for those who just started doing it. But recently, things started to change. And people actually thought, well, it's now time to reject invalid announcements. And it started basically at IXPs. I think they were the safest places to enable it because they are normally do not take money for traffic or something. So it looks like it was safe to start it there. But last year, many big operators started to do the same. And if you look at recent presentations and like NL NOG at NANOG, many companies did presentation about their successful deployment of RPKI. So the question is what will break when you reject invalid announcements is basically already answered. AT&T said mostly nothing will happen. Another medium Dutch ISP says, well, we've got 5 customer calls in 6 months. It's not a problem to fix it at all. Another research has been done which basically shows that even if the number of invalids big, it actually does not impact much of your traffic because, this is just, they would have been invalid anyways, with or without RPKI. Another problem with RPKI, which prevented it to be deployed more widely, is basically that RPKI at this stage that I described only does origin validation. So it does not solve all problems that you could see in BGP, and this is true because it only does origin validation, but the work in progress is still there. There is currently a draft at IETF on ISPA or Autonomous System Provider Authorization, which basically will allow to verify every element in AS path, whether it's correct or not. And the main idea now is basically that you have to start with what we have, even if it's just origin validation. You have to deploy it now and do not wait for after tomorrow because it will not make your life easier, but this will. Some statistics on the number of certificates. I'm afraid I'm gonna show the same graph as we already saw, something that goes up all the time. But yeah, this is how it is. We are currently having about 8,000 certificates in RIPE NCC, which is about 1/3, I think, of our members, which is quite good, but it could be better. So the coverage of IPv4 space globally, you could see some places are very green, like Greenland. Some people are not that green. Some countries, sorry, are not that green. So the coverage globally is still very low, and this is why I'm asking you, it has to be better. The accuracy of this data is actually very good. So if we compare the data in RPKI with what we see in routing in the wild, they basically match almost at 100%. And this is the table if you look closer at this region. Yeah, you see there are almost like 3 bands in there. Some countries are doing better, some countries are doing worse. So yeah, there is some room for improvement, I would say. This is the result of the yesterday's ROA signing by our Georgian colleagues who had presentation yesterday, also lightning talk on IXP. So as you could see in our RIPE-Stat interface, now the RPKI status is green, so well done. RPKI filtering at IXPs, as I said, they were the first one to use it in the wild, in the practice. There is some analysis by Job Snyders and Samer Abdel Hafez and Marty Strong. The link is there. Basically what they say is 9 out of 10 IXPs already filtering data based on RPKI, but not in the ENOG region. It's only 3 IXPs according to their data that are doing this already. And yeah, recommendations start today. Well, maybe tomorrow, but not later. It's not that difficult. There are tools also to monitor this whole setup, so just make a difference and make example for the others. Thank you very much.